Welcome back, guys. So here now we have the challenge. As a reminder, our goal is to segment out the objects in this fuzzy image. So we have the fuzzy image with us here, and only draw the large objects and give each of them a unique color as both print out the parameter and area. To do this, we will make back an exercise file, and here just what we are doing, we want to convert this image to the grayscale. We want to go do all of our thresholding. To do that, we are using the gray equals cv2 cvt color, and then cv2 dot color underscore bgr2 gray. Next, this little trick will actually help make our adaptive thresholding work better if we use the blur as we used here in the past. Let's use the Gaussian blur here by typing the blur equal to Gaussian blur. Then we pass over the gray image, and then the structuring elements we can use 3. So you can also play with the value of, see what else works better, and then we will pass in the value of 0 and then close the parenthesis. Here you can check other values as well. So to use this, we will type the just only the threshold and cv2 dot the adaptive threshold, where the t is capitalized, and we will pass in our blur image and the maximum value of the image type, which is the 255, and then we all the adaptive thresh Gaussian underscore c, and then again all caps thresh binary inverse. We are selecting the inverse in this case because the foreground of the image was white, and we want to take out the objects which are going to darker than this color. Before is investing the threshold, finally let's set up the appropriate neighborhood size here. We'll start with 205, then we will pass the value of 1, and here you can go through and then see at the binary image as well, but we will continue because our purpose is to deal with all small dots and use the contours on this image, and then see where we are at. To run the contours here, the contours, and then we are not going to use any of the hierarchy elements, so we use the underscore equal, and then here we are using the cv2 dot find contours, and open parenthesis, use the thresh comma cv2, and then escape the retrieve, and then cv2, and then all caps chain approx simple. Now let's go ahead and print out just our own reference, the length of the contour objects, and just so we know how many objects it has actually found, and print the length and left the contours and close it. And then according to task, we want to make sure that only draw the largest contours. So to do that, we actually want to run some filters on the contours. To that, we are going to create an empty array called the filtered equals and open close brackets. Then for C and contours, enter the cv2 that contour area of the CM less than the 1000, as if the area of the contour is less than 1000 square pixels, as indicated by the instruction video. We will skip the continue to the loop. If it's the largest this value, then we will use the filtered append, and we are going to append our contours. Now we can print out the filtered contours length by typing length of the filters here, and also if we will see like that we have over of almost 2000 contours found, but since it's down for let's complete the script by actual drawing our contours. To do this, let's finalize the blank image by typing the np numpy arrow zeros, and then we are going to pass it shape of our image by using the shape 0 and image shape 1. Then the number of channels we want to draw, which is going to 3. So we can have it in color. Finally, when you use the unsigned integer with the depth 8, they're actually going to add an important to the top of a module, which is going to be the import random, which we have already random imported over there. So to do this, we will type the C in different filters, because we only want to draw the filter counters. We can initialize our colors as equal to random.randent, which will range from 0 to 255, and random.randent for second channel from value 0 to 255, and finally random.randent from 0 to 255 again, though the last channel of the color. So we can draw the contours by typing the cv2.draw contours with an S. Then we will pass an object comma, and we will use our trick of putting our contours in single length list comma -1 to indicate we are drawing all of our contours in single length list. Then we will pass our colors, and we will indicate want to find incomplete, and then we will print out the required areas. And to do this, we can just cv2.contour areas pass into the contour, and p print equals to cv.arc length, and then we will pass c and then value of true, indicating that it is closed arc. And also we will print out the areas followed by p by parameters, and finally we will do an mshow to draw the contours, and cv2.mshow contours comma then objects. And now you can save, and then just and lost the cv2.wait key and destroy all windows, and then you can just run through this script. So here we go, and here we are just going to run our this code, and then see. If we see here, these are the contours, and this one is the binary, and this one is the original, and we can see the final results of our contours segmented out. It is interesting to note we have little bit of the surprising result. In middle of the large green square on the right, there appears by another smaller contours that was drawn within. Essentially, there was actually a unique object that OpenCV found and draw on its own, and it happened to be the larger than our threshold. For reasons like this, you will often find that people will actually run contours twice. The first time it will merge overlapping contours, and then second time there will be whole incomplete objects. As we can see, we have completed the challenge because we have drawn these squares each with different colors, and we have filtered out all the smaller noise. And we can go back to the terminal and see the printed value as well. If you see here, these are the printed values and parameter and area for each of the objects here. So that's it, the assignment solution. Thank you guys. I'll be back with next section of the face detection and the feature detection features. Thank you, and bye for now.